Okay, sometimes it really is better to use a very tiny neural network instead of a large language model. Think of this problem. You're using an AI agent, voicebot, say, to talk to a user, and you've just given some information to the user and you want to get them to confirm. So you ask them a yes/no question. So you need either yes or no or indeterminate are the three categorizations, the three buckets you're going to put the answer into. Uh, in this kind of model, you need somewhere between 5,000 and 10,000 phrases to train a really good model. You're going to have a model that's got 10,000 or tens of thousands of parameters, not hundreds of billions of parameters like GPT or other foundational LLMs. There's no point in sending that problem to an LLM. Two reasons. One is that a dialogue, particularly a voice dialogue in an AI agent, is very time sensitive. You really have to come back quickly to give the user a good impression and to have a good experience. And secondly, the problem that you're sending to the model is not large enough to warrant using the hundreds of billions of parameters, right? So it makes no sense. So you send it to the little small neural network in this case, and you get a response back in well under a tenth of a second. You're never going to get that on the LLM. Now you may use the LLM in parallel or secondary, right? So it might be complementary, because if you get the indeterminate answer, not the yes/no that you're looking for, then you need to figure out what that means and how you should respond. That might be where you use the LLM. So this is what we do in our product, and we find that to be really the right way to go from a usability point of view, but also the right way from a resource management perspective as well, and a cost perspective. If you were trying to figure out your strategy to use these kinds of AI components, LLMs, and everything else, then think about this. Right? Sometimes tiny neural network is right. Sometimes very large LLM is right.